Hi friends, welcome back to our channel Physics Tutorial. Today we are going to discuss the NCERT textbook exercises and solutions of 9th standard physics. In the last class we had discussed the first 3 questions of the chapter motion. So can we continue with that? Now we have the 4th question. Now we can move to the question. Okay, the question is, a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? So I will repeat the question. The question is, a motorboat is starting from rest. That means it was initially at rest and it is starting from rest on a lake and accelerates in a straight line at a rate of 3 meter per second square. So initially it was at rest means the initial velocity will be 0. Okay, so in such cases, suppose the object is starting from rest means we have to take the initial velocity as 0. So u is 0 and acceleration is given as 3 meter per second square and time is given as 8 seconds. So here, how far does the boat travel during this time? That is the question. So what is the how far does the boat travel? That means what is the distance traveled by the boat? So that we are going to calculate. So first of all, we can mention the given data. So here we have the initial velocity, that is u. We can write the solution, and here it is given that initial velocity is 0. That means 0. U is equal to 0 and acceleration is given as 3 meter per second square and time is given as 8 seconds, right? Yes, time is given as 8 seconds. Now we have to calculate the distance traveled by the boat, that is S. So if you are getting such a question, first of all we have to write down the 3 equations of motion. That will be easy to do. So here we have 3 equations of motion. What are the 3 equations of motion? Yes, V is equal to U plus AT. And second equation is S is equal to UT plus half AT square. And third equation is 2AS is equal to V square minus U square. So we can keep it in one side. And now we can look into the equations. What are the data here and which can be used? So here we have to find S. So we have U, A and T. So which equation can be used from here? Here we have U, then S we have to find means the second and third equation only can be used. Okay, so here we have U, that means U is here, T is given, that is T is here, then A is also here. So here we only have to find S, all the other things are there. So we can use the second equation, right? That means S is equal to UT plus half AT square. Now we can directly substitute. What we will get? S is equal to U is 0. So 0 into 8 plus half into A is 3 into T square, that is 8 square. Right. So what we will get? Yes, we can calculate. Here we are getting 0. So that will be equal to half into 3 into 64. Okay. So that will be equal to, yes, 96 meters. 96 meters. So that is the distance traveled by the boat. Okay, so it is very easy to do, right? So here we have to directly substitute the values of U, A and T. Clear? Now we can move to the next question. The question is, a driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Then another driver going at 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled further after the brakes were applied? So here we have to draw the graph of, that means the speed time graph of these two cars. Okay, so what are the things given here? Here a car which was traveling with a speed of 52 km per hour. What does it mean? Initially it was moving with a speed of 52 km per hour. Okay, so initial velocity can be written as u is equal to 52 km per hour. So here we have 52 kilometer per hour as the initial velocity u, right? So kilometer per hour we have to convert into meter per second. So what we will get? So that will be 52 into, here instead of kilometer means 1000 divided by, yes, 60 into 60, right, seconds. So what we will get? This can be cancelled. So that will be 5 by 18, right? So that can be written as 52 into 5 by 18. So that value can be calculated. 52 into 5 by 18. So how much we will get? Yes, 14.4 meter per second. So that is the initial velocity. U is equal to 14.4 meter per second. Okay, now what else is given here? Time taken to stop is given as, that means here this is a case of first car, that can be taken as A. Okay, and the time taken is given as, that is 5 seconds. Okay, that is the first case. And in the second case, what is given here? Initial speed, that means the another car was traveling with a speed of 3 km per hour. What does it mean? The initial velocity of second car, that means UB is 3 km per hour. So that also can be converted into meter per second. So that is equal to 3 into 5 by 18 directly we can do here. Okay, so 5 by 18. So what we will get here? That is 0.833. 0.833 meter per second, that we can calculate. So here we are getting initial velocity of the second car as 0.833 meter per second. Okay, then time taken is also given. How much is the time taken here? That is t is equal to TB, that is equal to 10 seconds. Okay, now final speed of the car becomes 0 after 10 minutes. Okay, now we have to plot the graphs of the two cars. So how we can draw the speed time graph of these two cases? So first of all we can draw the first case. So how we can take the quantities? Along x-axis we have to take the time interval, and along y-axis, yes, speed we have to take. Speed along y-axis. So here we have the speed 14.4 meter per second at a time interval of 5 seconds. Okay, so how we can draw the graph here? So we have to select any scale. So which scale can be taken here? In y-axis we have the value till 14.4. Okay, so which scale can be chosen here? That will be 0, then 2, 4, 6, 8, 10, 12, 14, 16, like that we can take. Okay, this is the speed, and time can be taken as 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, like that. Now we have to take till 10 seconds because the second car stops at 10 seconds only. 7, 8, 9, 10. So how we can draw the graph? These are the given data here. The initial velocity is 52 km per hour. When we convert it into meter per second, we are getting it as 14.4 meter per second. And the time interval, that means after applying the brake, that he was accelerating in the opposite direction, means that is coming to rest. Okay, so that means the time interval is 5 minutes. So after 5 minutes that will come to rest. Okay, and in the second car, what happens? The initial velocity was 3 km per hour, that means 0.833 meter per second, and after 10 seconds it is coming to rest. So we have to plot these two cases in a single graph. Okay, so how we can draw this? So here we are taking speed along y-axis and time along x-axis. So we can select any scale here. So it is better to select 2, 4, 6, 10 like that. Okay, so here till 14.4 we have to take the scale. So here we are taking the speed in meter per second along x-axis and time in second along x-axis. Okay, so here we are taking this time as 1, 2, 3, 4 like that. Clear. Now first situation we can draw here. Here the initial velocity was 52 kilometer per hour, means 14.4 meter per second. Here we are taking meter per second, right? So 14.4 we have to mark along, yes, y-axis. So 14.4 we are taking here, and after 5 seconds what is happening here? Yes, that is coming to rest, right? So here this is 5 seconds. So here the acceleration is decreasing. So this can be drawn like this. Clear? This is a straight line. So you can see the graph here. So that is the first case. So here after applying the brake, what happens? That is coming to rest after 5 seconds. Okay, so 5 seconds the speed is becoming 0. Clear? And in the second case, the initial velocity was 3 km per hour, and after 10 seconds it is coming to rest. So here for 3 km per hour we have 0.833 meter per second as the speed. So here we can mark that point, and after 10 seconds only it is coming to rest. So how we can draw the here? So this will be coming like this and decreases to 0. So this should be a straight line. Okay, so like that we can show the diagram. Clear? And here one more question is asked, right? Which of the two cars travel farther after the brakes are applied? So how to calculate that here? We have to find the area. We have the speed time graph. Okay, so from speed time graph we have to calculate the distance travel. So for both the cases, in both the cases of the cars, we have to find the distance travel. So how we can find the distance from a speed time graph? Yes, that means the area under that graph will give the distance. Okay, so here we have the first graph. That means for car A, we have a triangle. So how we can find the area? Yes, that is half BH, right? So here SA, that is the distance of car A, that will be equal to half into BH, that is half into OP into OR. So we can substitute the values. OP is here how much? Yes, 14.4. Right. Then OR is, that is 5. Okay. So that will be equal to half into 14.4 into 5. That is equal to 36 meter. And in the next case, for the second car, how we can find the area? Yes, again here we have a triangle, right? So how we can find? SB is equal to half into B into H, that is half into OS into OQ. So we can substitute the values. So half into 0.83 into 10. Okay, so how much we are getting? Here we are getting 4.15 meter. So which one is having more area? Yes, the first car is having more area, that is 36 meter. That means that much distance it has moved. Okay, and in the case of second car, it has moved only 4.15 meter. So which is the answer for that? So which car will be traveling further after the brakes are applied? Yes, that will be having the first car. Okay, so car A will be moving further after the brakes are applied. Okay, clear? Now we can move to the next question. The question is, the following figure shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following. So here we have a graph here. The distance is taken along y-axis and time along x-axis, and time is in hour and distance in kilometer. So here in x-axis we can see the values, that is 0.4, 0.8, 1.2 and 1.6, and that is in hour. Okay, and in y-axis we have the distance in kilometer, that means 4, 8 and 12 kilometers, and the 3 objects that the values are marked here, and B is starting from 0, that means initially it was 0. So the distance travel at the time 0 was 0 for object B only. For the other three cases, that means C and A, the initial distance was not 0. Okay, so that we can see when we are going to the question. So these are the graph, and from the graph we have some questions. The question is, which of the three is traveling the fastest? So here we can see the three graphs, and among these three, which one is traveling fastest? That is the question. So here we have distance and time. Okay, so how we can find the speed from this? So distance time graph means if you are finding the slope, what we will get here? Slope we can find like this. Okay, so here we can take two values. This is y2 and minus y1 divided by x2 minus x1. Okay, so that value will give us the slope. So similarly, we have to find the slope of each graph. So for the three graphs, we can find the slope, and which slope is higher, that will be the fastest one. Okay, so like that we can find the slopes and we can calculate the slopes roughly. Then if distance by time will give us the speed. So when we look into that, we can understand that which one has more slope here. Okay, which one is having more slope? Yes, from the graph we can see, right? So here B is having more slope, right? So B will be moving faster, right? So that is fastest. B is fastest compared to this A and C. Clear? And the second question is, are all the three ever at the same point on the road? Are all the three ever at the same point on the road? So if all are in the same plane means they should meet at a single point. Okay, here can we see any point where all the three are meeting? No, here two are meeting, but here also two are meeting, here also two are meeting. But all the three are never meeting together. So what we can say? Yes, all the three objects never meet at the same point. Therefore, they will never meet on the same point on the road also. Okay, so here they are not meeting at all. And what about the third question here? How far has C traveled when B passes A? How far has C traveled when B passes A? So here we can see that B is passing A. Okay, so this point, at this point we can see the point, that means B is passing A. Then in that time, how far C has traveled? That is our question. So distance we have to calculate, right? So here we can see in left hand side the distance. That means each 7 boxes are equal to 4 kilometers. Here the scale taken is 4, 8, 12 like that. Okay, so each has 4 kilometer difference. So when we count the number of boxes, here we can see that 7 small boxes makes 4 kilometer. Okay, so what will be the value of one small box then? Yes, that will be 4 by 7 kilometers, right? And here we have initially we have told that only that B has traveled starting from rest. Okay, initially the distance was 0 for B only, but for C here we can see there are 4 blocks away from the origin. So initially it was 4 blocks away from the origin. So how much distance it might have moved? Yes, that into 4 by 7. Okay, so 4 into 4 by 7 kilometers. That will be 16 by 7 kilometers it has moved initially. Okay, and now distance of C from the origin when B passes A is 8 kilometer. That we can see in the diagram. Okay, distance of object C when B passes A. So that has 8 kilometer. So what will be the distance covered by C? So that is, we have to subtract, right? That is 8 minus 16 by 7. That is 5.714 kilometer we are getting. So C traveled a distance of 5.71 kilometer when B passes A. Okay. Now we have one more question. How far has B traveled by the time it passes C? How far has B traveled? How much it has traveled by the time it passes C? That is the next question. So here we can see from the graph, distance covered by B at the time it passes C is that here it is marked, right? We can count the boxes. How many boxes are there? Yes, there are 9 boxes. So each box is having 4 by 7. Okay, that much kilometers. So distance will be equal to 9 into 4 by 7. That is 36 by 7. So the distance traveled is 5.143 kilometer. Okay, therefore B has traveled a distance of 5.143 kilometer when B passes A. Clear? So now we can conclude the video here. Hope it is clear to you, and in the next class we can discuss the rest of the questions, and also the in-text questions we can answer in the coming videos. So if you like the video, please like, share and subscribe. Thanks for watching.